Hello Charles Angels and welcome to another tutorial. Today we're going to be working on this very awesome, if I say so myself, car racing game. I've been inspired by Brick 99 games and I've created one earlier. You could check that out. That is the Tetris. And I was like, you know what, let me make the racing game too. So that's what we're doing. We can increase, if we press a button, we can increase a key. We can increase the speed. The score increases whenever the car passes, and if we hit a car, there is an explosion that takes place. So this is basically what we are going to be building, and I'm glad to have you on this journey with me. So let's hop on the code and let's make some awesome game. So I have created this new folder in my system, then brought it into VS Code. I called it YT Racing. So that's YouTube Racing, sort of. So I'm going to create a new terminal, and let me just switch to command prompt. And here I'm going to create a new Vite project. So that's going to be npm create Vite dot means the same folder, right? And we're going to wait for that to create. So now I'm just going to call this YT race, and then I'm going to choose vanilla, then I'm going to choose JavaScript, and I'm going to say npm install. Now that has finished installing, then we'll just say npm run dev. So let's open that. So I'm just going to control then click on it. Then we have this. This is what is showing. This is coming from the main.js file. So I'm just going to remove everything here. Sorry, let me undo that. I'm going to remove everything except the style.css, right? So in our style.css, I'm removing everything in there. Okay, then if we go to our index.html, this is where we're going to do some things, right? Here we're going to create another div, and this div is going to have a class, and the class is going to be single box. We're going to style this pretty soon. We could have let's create 8 of these. So how I did that was Alt Shift then down. That's on Windows. Okay, so one of this I'm going to give it field. So that's another class called field. So, and that basically covers our index.html. Okay, if we go to our main.js, if we go to our style.css, okay, what we want to do is we're going to just say app, then we're going to say display grid, and we're going to say grid template columns. We're going to say repeat 630 pixels. Then we're going to style single box, and then we're going to say height is 30 pixels, width is also 30 pixels, and then we say border is going to be 1 pixel solid black. Then we'll say single box dot field. So whenever the class list has another class called field, then we'll say background color. That's going to be 213547. Okay, so if we go back to our browser, we have this. So I'm sure you can imagine how we do the cars, the enemy vehicles, whatnot. So yeah, so that basically covers our HTML and CSS. Let's move to JavaScript. In our main.js file, so let's just move to our main.js. What's happening? Okay, so in our main.js file, the first thing we want to do is we want to create a variable. We're going to call this variable board. This board is going to, you see what this board does. It's just going to house what would the representation of what we're looking for. So I can say, we're just going to put empty strings. I'm going to say this, and this, and then this, then this, and then this. These are just empty strings. So this represents our board. This is 1, 2, 3, 4, 5, 6. Yeah. So I'm going to duplicate that again. That 8, 1, 2, 3, 4, 5, 6, 7. Let's just say 8. Okay. Fantastic. So now that this represents our board, what we need to do is create a function, and what this function is going to do is just kind of create the board for HTML. So this function is going to be called board creation, and then at the top here, let's say const main app is equal to document dot get element by ID, and then we'll just say app. Right, so back here we're going to say main app dot inner HTML is equal to empty string. So essentially we just want to clear everything that has been here already. We want to clear all of these, right? Then we're going to say board the for each, then we'll say this. Now here we're just going to put box as an argument, or yeah, all right. Then we're going to say const div lm is equal to document the create element, and we want to create a div, right? So essentially just doing what we did before, but this time with JavaScript. So that's div lm dot class list dot add single box. Okay, so now I want to put a okay. Okay. Then I'll say main app dot append child. Then I'll say div element. Okay, so let's just call this function. That's just going to say board creation. Initially I wanted to add a dot, but I would wait for it. So now let's take a look at what that looks like. This is what it looks like now on our screen. So how do we, when something is filled, how do we do that? So if I put a dot here, that is, I want the second item to be filled. So what I just do here is I just go if box. Remember, box is the item of this board, which is the string, right? So we're saying, okay, if the box is equal to a string that has a dot, what we want to do is we'll say div lm dot, this div that we've created will now have a class list. So that's div lm dot class list dot add field. So if we save, if we go back to our browser, you can see it's there. So that's us creating the board, right? That's us creating the board. But so far we are hard coding the board, and that is not good enough. There should be a much more dynamic way we could create the board, you know, so that we don't have to manually type. This just feels wrong. So that's what we're going to work on now. And back in our code at the top, we're going to bring a variable. We're going to say const grid width, not good, grid width is equal to, for this situation we don't want it to be 6. Let me remove this dot. We want it to be 9, so I want it to be 9, and then I'll say const grid height. I want the height to be 16. You can make it 10. Let's start with 10. We can always expand it. Then we would say, should I increase the font so you guys can see it some more? Okay, and let me remove this and say, yeah, so this is the grid width and height. So now when we go back to board creation, what we're going to do is we are going to adjust the layout. So we're adjusting the CSS, that is this one, so that give us what we want. So that's main app dot style dot grid template columns is equal to, then I'm putting backticks, then I'm saying repeat, then what I want is the grid width to be here. So whether 6 times or 9 times, whatever it is. So that's then 30 pixels, which kind of matches what we have here. Okay, so that's for the layout. And then we say const initial board is equal to a new array. So instead of this one, we're just going to create a new array. So new array, then we're going to say grid height multiplied by grid width. So this will give us the entire length of the board, and then we'll say dot fill, and we'll just fill it with empty strings. And instead of board here, we're just going to say initial board. And if we save, if we go back, this is what we have now. We have a 9 by 10 grid. Yeah. Okay. We now need to display the vehicle that we're going to be moving on the screen. And to do that, the first thing we want to do is we want to create a variable, and we're going to call this variable vehicle. Yeah. So let vehicle equal to an array. All right. So what's going to be inside this vehicle are just going to be coordinates of this board. So wherever we want field, we'll put the coordinate here. The coordinates are just numbers. So for example, if we want this one, this and this to be field, then we'll put 1 and 2 here. So let's try that out. So we say 1, 2. Okay, next we want to create a function, and the function is going to be called calendar. Right, so function, did I say cars render? The reason is because we're not just going to be displaying the vehicle we're moving, but the enemy's vehicles too. Okay, so I'm just going to say main car. I'm going to say vehicle dot for each. Then I'm going to say this is going to be position. So I'm just going to say board. Then we're going to put the position here, and it's equal to a dot. So wherever the vehicle is going to have a dot. Then we're going to create a new function. The function is going to be called paint screen. So it's just going to resemble the board creation. The only thing here is that it's for painting the screen after the vehicle has been created. This vehicle simply imprints on the board, and then the paint screen paints that description on the dome. Yeah, so function is paint screen. Then we're going to say const all boxes is equal to document dot query selector all, and then we're going to say single box. All right, so we're going to say board dot for each. So this is going to have the box and then the index. Remember, the box, it just represents the strings. So if box, remember it's a string, if box is equal to dot and all boxes index, that is if this is also available, if there's something like that in the DOM. Then we say all boxes, so all boxes dot class list dot add field. Then else we're doing the opposite, so we're just going to copy this and we're going to paste, and here we're going to say remove. Okay, so we're just going to simply put this in cars render, and then we're going to call cars render. Okay, fantastic. So if we go back, we can see now these two places are filled up. So how do we represent the vehicle? Remember, I said they are just numbers. So let's hard code a vehicle, but first let me change this to 6. Then I'm going to just bring in a set of figures. Then so that's going to be 28, 33, 34, 35, 40, 45, and 47. So if we go back, we can now see our car on the screen. Fantastic, yay! But obviously this doesn't make sense to hard code it. We want it to be programmatic, you know. So we're going to do a bit of maths, but I'm hoping you will understand. So let's imagine the vehicle is here, or we want to put, let's just make this simple. If we want to put a dot here, for example, let's just take this part for example, right? Normally if we do like normal math, that's going to be this is 6 times 2 times 3, this is 18. So we would put 18 here, but we're hard coding and that's not what we want. So what we could do is we would say the grid width multiplied by the grid height, right? And then we would minus 1. Then we get this particular place, right? Now in the same vein, we could do something like that if we're starting from the base. So if we're starting from the base and we want to target this point, what we would say is we would say the grid height in this situation 8 minus 3, so 1 2 3, it gives us, then we would say multiplied by the grid width, which is here, right? So that's the grid height minus the, so if we say the grid height minus the minus 3 would give us this line, right? And then we'll say multiplied by the grid width, which is going to give us here, right? So let's say, for example, in this situation it's going to be this is 6 12 18 and 24, this is 30, this is 5, so 30. So if we are going to target here, we're going to say minus 2. Why we're saying minus 2 is because if you say minus 1 is going to give us here, and because you know we're using index, our index starts from 0, then we say minus 2 is going to give us this. I hope I was able to make sense. All right, so let's just imagine we are doing that right now. Let's put that into this. So we're going to say the grid height minus 3. Remember, that takes us to this point, that elevates to this point, right? Grid height minus 3, then we say multiplied by the grid width. That will immediately, so remember, the grid height minus 3 will bring us to this row, then multiplied by the grid width will just bring us directly here. It will bring us here, because you know we haven't done minus, it's not starting from 0. So then we group these two together, and then we say minus 2. So it will go from here to here to here. I hope that makes sense. Okay, with that, we're just going to continue. I'm going to quickly just continue from there. So now, if we want, what we want to target is this point. So that's going to be grid height minus, it's not 3 this time, that's going to be minus 2. So it brings us to this line, multiplied by the grid width, and this time it's going to be minus, we're going to do minus 3. So it's going to take us to this point. I hope that makes sense. So we have done here, so now we're going to go here. So obviously this is, sorry, oops. So I'm just going to copy this, and then this as targeted here. So to target here, we're just going to say minus 2 instead. Okay, and of course if we're targeting here, it will just be minus 1. So I'm just pasting the same thing, and then this will be minus 1. Let's see what that looks like so far on the board. So you can see works like a charm. And then we're targeting the next place, so which is this point. So of course this is going to be minus 1. Okay, so I'm just going to copy this again. And instead of minus 3, it's going to be minus 1. So if we go, you can see if we go back, that has been formed. And then the last area, we're just going to say grid height multiplied by grid width minus 3, because we are already on the last level. And then we say essentially the same thing, but this why did I just I'm just so grid height multiplied by grid width, then minus 1. Yes, yay. And so yeah, we've been able to paint, the car on the what's it called, I've been able to paint the car on the screen. So even if the reason why we're doing it programmatically like this is, even if we decide to change the width, for example, and now we want it to be 9, if we go back, you can see it just works. It just works. We don't need to change anything any longer for it to work. Now our car is just laying idle on the screen. It needs to move. It needs to move. So right now, our vehicle is on the right. We need to move it to the left. Yeah. So let's move our vehicle. Let's create something to move our vehicle. So back in our code, we're just going to scroll down a bit. Yeah, our code is going to get a bit long. Sorry about that. You could, in your own time, you could always put each function in a model, but just for the purpose of this tutorial, I just want to keep things very, very simple. I know. So function is going to be move to the left, right? And we need a particular key that when we press it, it's going to move to the right. In this situation, we are using the A key. So we're going to attach this function to an event listener. So we're just going to put E here for events. And so we're going to say if e.key is equal to A, then we want to do something inside. The first thing we want to do is we want to move the vehicle. So moving the vehicle is very simple. Remember, our vehicle is just made up of coordinates that are numbers. So to move it to the left, all we have to do is just -3. So I'm just going to say move vehicle, and I'm going to say vehicle is equal to vehicle dot map. Then I'm going to say position, and then I'm going to say position -3. Right. So this is going to move the vehicle. So after this is done, we're going to then run cars render. This will then print it on the board. Then we're going to call paint screen, which transfers what we've been printed on the board onto DOM. So with that, we're just going to say window.add event listener. I'm going to say key down, and then we're going to put move to the left. Okay, so let's press A. We use the small letter A, so you can see it's actually moving, but you can see where it was before, it isn't changing. In order to do that, we're just going to clear where it was previously. So we're going to say clear previous blocks, and we're just going to say vehicle dot for each, and then I'm going to put position here, and I'm going to say board and position is equal to an empty string. That will just remove it from the screen. And so yeah, if we go back here, if we press that A again, yeah, it moves. We still have this issue where if we press it, keeps going up, and that's not what we want. We want a situation that when it gets to the end of the screen, it stops. And so let me just quickly explain what we're going to do. So now what we want is we're going to run a loop that will take note of the grid height. So our grid height, let's say 8 or 10 or whatever. So at each level of this grid height, we're going to check what number it is. So from 0 to 6 to 12 to 18 to 21, 24, and so on and so forth. And then we'll check the vehicle. The vehicle has numbers, right? So we'll check, okay, does this vehicle have any of the numbers that are here at the extreme left? If it does, then we don't need to do anything. That's what we're doing. Okay, so back to our code, we're going to say prevent car or prevent vehicle from going overboard on the left. Okay, we're just going to say for let I equal to 0, right? And then we can say I is less than or equal to grid height, and then we're going to say I plus plus. Okay, so here we're going to say when we're on the first level, which is level 0, I'm going to say the left extreme or the extreme left, anyhow you want to name that. We're going to first say I, that is 0 multiplied by the grid height. So in this situation, the grid height, sorry, I said grid height, grid width multiplied by grid width, so whether it's 9 or 6. So in the beginning, let's imagine I is 0, so this is going to give us 0. Of course, we'll say let's make this 1, so just makes sense. So 1 times grid width, this is going to be 6, or 9. Grid width is 9, so 9 times 1 is going to give us 9 minus grid width, and this is going to give us 9 minus 9 is going to give us 0. So the extreme left in this situation is 0, which is here. So I've gotten that option. So if I becomes 2, that's going to be 2 times 9, that's going to be 18 minus grid width, which is 9, which is going to give us 9. So it's going to bring us here. Well, if it's in this situation 6, that's going to be 2 times 6, 12 minus 6, 6. And this is what, so you get the point, right? Okay. So if vehicle dot sum, right? So dot sum position is equal to left extreme. So exactly what we're just trying to say is, if any number in the vehicle has extreme left, if any of the position is the number of the extreme left, then it means that we're at the extreme left, and what we want to do is return. So I save. If we go back to our browser, then you can see if I press A, and now nothing happens, it just works. But we cannot move right yet. We need to, it's not just left we want to move, we need to be able to move right. To move right, we are going to create a new function, and so back here, so this function, we're just going to call it move to the right. Move to the right. Okay. So like move to the left, this is also going to be in an event listener, so we're putting E there. So we're going to say if E dot key, so this time we're going to use our letter D for moving to the right. So now to move the vehicle, we're going to be doing exactly the same thing. The only difference now is we are, instead of -3, we're going to say +3. And if we just duplicate this, and then we say move to the right. Okay, so if we do this, so if we, oh, okay, what? Okay, sorry, we did not put this, so we have to also put this. Sorry about that. So if we press A, and then of of course, you see the same thing happens. So like I said, we're just doing kind of like the same thing. So we're just going to clear previous. So we're just going to put this above. And then you can see it goes. But now you see it's moving out of bound again. What we want to do, the reason why our code doesn't break is because we did this here. So it's only things that have this. That's what we're trying to do. That keeps our code, in check. Now, of course, in order to prevent the car from going out of bound, we're going to be doing the same thing we did, or not the same thing, but something similar. But this time, instead of concentrating on the left hand side, we're concentrating on the right hand side. So we are going to get everything on the extreme right, and then if the vehicle has a number that is on the extreme right, then we will prevent it from going. So we're going to say prevent vehicle from going up beyond extreme right. Okay, so I'm just going to say for say let I equal to 1. Then I'm going to say I is less than grid height, and then I'm going to say I plus plus, and then I'm going to say const right extreme. I don't know why I'm naming it this, just the vibe is right to me. So I'm going to say I multiplied by grid width, that's going to be -1. Okay, let's explain what's going on. So 1 multiplied by grid width, that's 1 times 9 or 1 times 6, you get. So in this situation, it's going to be 1 times 6. So it's going to be 1. If you say 1 times 6, that's going to give us 6 here. Remember, our index starts from 0. So we say 0, 1, 2, 3, 4, 5, 6. Then we say -1 because we want it to be here. We want to get this particular position. So if we're in level 2, it's going to be 2 multiplied by grid width, which in this situation is 6. Then that's going to be 12. 12 normally would be here, but -1 will bring it here to 11. Okay, and so on and so forth. So I hope you get the gist. So I'm going to say this kind of the same thing. We're just going to copy and paste, but the only difference is instead of extreme left, we're just going to do right extreme. We're going to save, and then if we go back to our code, if we do that, it doesn't go. If we come back, it doesn't go. And yeah, so now we've been able to prevent it from going overboard, both on the left and on the right. It's not enough for our vehicle to be moving from left to right. We needed to, dodge enemy vehicles. I know the vehicles are sport cars, but let's just call them enemy vehicles because the aim is to dodge them. So back in our code, we're going to create a new array. So this array is going to be a 2D array, and so it's just going to have coordinates of coordinates of the enemy vehicle. Yeah, so let's just start with, so I'm just going to say let enemy vehicle equals to an array. So normally we can hard code the number like we did for the vehicle in the beginning, but you already understand that they are numbers. So I'm just going to go straight into putting in how we're going to programmatically, work with this. So we're going to have 1. Then the next line is going to be grid width. So remember, if the grid width is 6, for example, it's going to be here. So 1 is here, grid width is going to be here. If it's 9, it's also going to be here too. Yeah, you get it. So then we say grid width plus 1. So that's going to be grid width plus 1. And then we'll just say grid width plus 2, which is grid width plus 2. You get it. And from there, I'm going to say grid width multiplied by 2. So we're going 2 levels down. Then we would say plus 1. So grid width multiplied by 2, that will give us here. Then say plus 1. And that grid width multiplied by 2 would give us here. Then we say plus 1, which will give us here. All right. And then, so same thing, grid width multiplied by 3. I'm sure you get the gist by now. Then plus 2. So this is going to be multiplied by 3, then plus 2, plus 2. So if we say plus 2, it's just going to scoot it to this point. Yeah. So simply we go back to our cars render. So remember, our cars render is just to render the cars, right? So we're going to imprint the cars on the board. So that's going to be enemy vehicle dot for each. Remember, we're dealing with a 2D array, so we're going to have a nested loop here, which is fine. So we're going to have vehicle here. So we're just going to essentially copy this and paste it here. Then I'm just going to put this as enemy vehicles. Save. So if we go back, we have this on our screen and looks just right. Yay. We need the enemy vehicle to move down. It's not good enough that it's just stuck up there, like wondering what it's supposed to do while this is having fun. We need it to come down. So to do that, we are going to create a new function, obviously, and then we're going to call this function cars moving down. I don't know why I didn't name it enemy vehicle moving down, but so here we're going to have enemy vehicle dot for each. So I'm going to put vehicle here. So we're going to have a nested loop. So I'm just going to say, so what we're doing here is we're clearing previous blocks. Position of vehicle. So we could just simply just copy this and then paste it here. All right, and then we can now say enemy vehicle is equal to, like we did before. So remember, we're just going to say enemy vehicle dot map. So a map would return an array. So I'm just going to say dot map, and then we're going to say vehicle, and then we're going to say return vehicle. Vehicle dot map. Yeah, but it's essentially doing the same thing here, but let me just type it out. So I'm just going to say position. So this time the position is moving by the grid width. The reason is because if you move it by the grid width, let's say for example this is 1, if you move it by the grid width, this brings it automatically down. So if we say plus, in this situation the grid width is 6, so if we say plus 6, that's going to be 1 plus 6, that brings it to 7, which is here. Abi, and this is 1 plus 6, 7, so 1 2 3 4 5 6 7. Yeah, and like that it just keep moving one position downwards. So that's what we are doing here. So that's going to be position plus grid width, and then we're going to, as usual, we're going to render the cars, and then of course you know what comes next, paint the screen. We could actually put these two functions inside another function, but it's all good. And so let's just call this function and see what happens. Remember, this is where our car is. Let's bring it here and see what happens. See, now our car, or the enemy car, has moved one position downwards. But moving one position downwards is not enough. We need it to keep moving down. That's what we want it to do. And to do that, we're going to bring in our trusted friend, set interval. You know, people use set interval for animations a lot, but we're going to start with set interval before we move to using request animation frame. Okay. So we're going to say set interval. Now we're going to put this as 600 milliseconds. And then we're just going to put cars moving down here. So now you can see, if let's restart that, I can see our car is moving down. Yeah. If we check, yeah, it's having this. We don't want this to happen. And in order to prevent that from happening, we are going to create a function that will check for if our vehicle is at the end. Once it's at the end, then we remove that vehicle from the area of vehicles, and then, you know, the game will keep moving on. All right, so to do that, back in our code, we are going to create a new function. The function is going to be, so let me remove this. We don't need that now. So I'm just going to say function check for end, and then we're going to say for let I equal to 0, and while I is less than the enemy vehicle dot length. So essentially we are just looping through the array of enemy vehicle, or array of enemy vehicles. So I'm going to see, so the whole idea is I'm going to check for the maximum number in our vehicle and find out if it's on the last line. So we're going to get the coordinates of these, and then we are going to find out if the maximum number of our car is inside one of this, then it means we have gotten to the end. In order to do that, before we move on, I'm just going to create a couple of variables. I'm going to say const board length is equal to grid width or grid height, or anyone, grid width times grid height, and then I'm going to say const last line. So this is where we're going to house the coordinates of the last line of the board. I'm going to say for let I equal to baud length minus 1. Remember, we're starting from 0, so that's why I say minus 1. So let's say it is 9 by 10 grid. That is going to be 90, so it's going to be 89 because we're starting from 0. Okay, so we're going to say while I is greater than or equal to, then baud length minus grid width. So what we're basically, okay, let me just say I plus plus now. Let me explain. So we're essentially just counting down from here to here. That's what we're doing. That's what we're just doing. Okay. So now that we're counting down, we'll just say last line dot push. We're just pushing in those numbers. That's going to be I plus grid width. So that gives us the last line. Okay, so back to our check for the end. We're going to say const max number is equal to math dot max. Then we're going to spread the enemy vehicle inside here. Remember, enemy vehicle is a 2D array, so we're getting the depending on where we are, we're getting the using the I. So now that will give us the maximum number depending on the situation. Okay, so now we're going to say if the enemy vehicle has reached the end. Okay, so we're going to say if last line that includes max number. So if the max number is inside last line, then it means we've gotten to the end. It means that, remember, the enemy vehicle is going down. Remember, we've been adding the grid to it, so it's moving from 1 to 7 to 14 and the like. So immediately it's one of the numbers, is it whatever, immediately a number in enemy vehicle has reached last line, then we know what to do. Okay, so that's going to be enemy vehicle I dot for each position, and then we're just clearing the previous position, so that's going to be baud position equal to an empty string, and then we are going to remove this particular vehicle from the array, so we're just going to say I1, and so we're like at position I remove just 1, yeah, so we just return, yeah, and with this we would drag this or copy this and paste it here. So we're going to check for if it's at the end. Why isn't it working? Invalid. So 157. Oh. I just realized. Remember I said we're counting from the end, and now the plus plus. This is supposed to be minus minus. Okay. Oops. So oops, sorry about that. So if we go back, if we refresh, you can see it now goes down. Okay, now I'm having this okay, what's that? Okay, line 82. Oh, oops, my bad. Okay, we're also supposed to check. So if, else if, I'll just copy this. Remember I was telling you if all boxes goes out of index, something would happen. So yeah, so now else if this is empty, then we want to remove that. Okay, so now, yeah, you see there's no error, nothing happens. Okay, yeah, so at least now the vehicle is going down. We can move it from left to right. Yeah, fantastic. Of course, in a game like this, one vehicle isn't enough. We need more vehicles, you know, to spawn on the screen whenever one has disappeared, you know. So to do that, back in our code, we are just going to create a new function, and this function we are going to call it spawn new vehicle. No, function. So spawn new vehicle. Okay, so okay, well, wait, let me see how many is this. Okay, well, 9. Okay, so we want a situation where there are going to be different positions for different cars. Some cars will be on the left, some will be on the right, some would be in the middle, and 2 could be on the left, 2 could be on the right. So we need to make provisions. We need to make provision for each of these, and then, you know, render it on the screen, show it on the screen, and, you know, as time will go on, we'd also need to dodge it. So let's work on each vehicle. I know this is going to instead of wasting our time, I'm just going to copy the coordinates for each vehicle on the screen. So let's not waste our time on that. Okay, so paste. So if you see, this is single left, so it starts at 1, just the same position as the original. This is single middle, 4, and the rest just the same math, just different positions. Then we have double left, double right. So double left and double right is just taking single left and single middle, and like that. So after that, now we want to, so now we need to have the positions for each of these vehicles, the top position for each of these vehicles. So we're just going to say const vehicle top positions equal to single left, single middle, single right, double left, double right. Right, now we're going to pick a random car, because, you know, I mean, it's not going to be the same car all the time. It's going to be randomized. So we're going to say const random car index is equal to math dot floor. Then we're going to say math dot random, then multiplied by vehicle top positions dot length. Yeah, this is just going to pick a random index for us. So now we're going to have a batch tracker. We're going to have a batch tracker. So the reason why we're having a batch tracker is because every time the car moves down, we need to know that, oh, okay, the vehicle has gotten to a certain level and we want a new one to come on screen. That's the reason why we are checking. So we're calling it a batch tracker. So once we hit a particular threshold, we want a new vehicle to come on screen. I'm just going to create a, let's just call this batch tracker, and it's going to be 0, right? Okay, so I'm just going to say batch tracker determines when the next vehicle pops on screen. Okay, so if batch tracker is greater than or equal to 6, then we will say enemy vehicle is equal to vehicle top position. So you can see the reason why I created that. Then we'll say random car index. So I wanted everything to be in one place so that I'll be able to choose. Then the previous enemy vehicles that were there, we're just going to put it right, and then we're just going to say batch tracker. We just restore it back to what it was before. Else, we're simply just going to increase batch tracker. Simple. So where are we going to spawn the vehicle? Of course, we're going to be bringing in new vehicles inside the inside the set interval. So I'm just going to spawn. So let's go back. So you can see it brings, so once it hits certain threshold, a new one comes on screen. 2, 4, 5, 6. Like that. So we get the gist. Now that we have the enemy's vehicle moving down, we want a situation. We want a situation that when the car hits, one car hits another car, or when the enemy's vehicle hits the vehicle that we are driving. Hey God. Then we want the game to stop. Yeah, that's what we want to happen. So to do that, we're going to create a new function, and we're going to call this function check for collision. That's what we're going to call this function. We're going to create, so let's create that function. I'm going to call it check for collision. So function check for collision. So we are going to have a variable at the top. We're going to say let is collision found equal to false. So in the beginning there's no collision. So what we want to do is we are going to be checking the numbers inside the vehicle, and we're also going to check the numbers inside the enemy vehicle. So there's going to be like a loop inside a loop. Yeah, I know I've done that a number of times, but for this particular thing it really doesn't matter because it's a limited search. So once we can find one of the numbers, so for example, if we find the vehicle number inside the array of the enemy vehicle, if they match, then it means that they have hit each other. it means that both numbers, the car and the enemy vehicle, are in the same place. They are occupying the same position. So there was a collision. So that's what we're trying to do. Remember, both vehicles are numbers. So if there are two numbers that are the same, then there was a collision. All right. To do that, we're just going to say for let I equal to 0, while I is less than vehicle.length, then we're going to say I plus plus. Then if there is no collision, so that if is collision found, okay, I was about to type if there is no collision. Oh god. So we're having another loop. So we're going to say, so this is an inner loop. So we're going to say let j equal to 0. Then j is less than enemy vehicle dot length. Then j plus plus. Right. So we're not going to say if the enemy vehicle j, remember, enemy vehicle is a 2D array. So if we are in the current enemy vehicle and then it has vehicle I, remember we're looping through vehicle I, so vehicle is just one, so there are a couple of numbers. So if this has one of this, so this is like a triple loop kind of, then we're going to say is so we're just going to say is collision found is equal to true, right? And then we're going to okay, then it means that we need to cancel the animation from happening. So let's just give this so okay, let's call this let clear time interval, so interval index. Okay, so if we go back, if we go down, so now we need to clear that. So I'm just going to say clear interval, and then we're just going to call that, and then the animation should stop once there's a collision. And once that is done, we can break, so we can break out of the loop. There's no need to continue looping. Okay, so this would now go into our set interval, so to be checking for a collision every second. So save, we go back. Okay, so let's patiently wait for one to hit the other one. Okay, now it stops. See, it just works. The animation has stopped. So what we want to do is that we also need, but if you see as it stops, we can still go like this. Yeah, we don't want that to happen. We really need to like say game over, we're ending the game sort of. So what we have to do is we'll create a new variable, and then at the top we would say is game end. Is equal to false. So when there's a crash here, we'll just say is game end equal to true. Okay, and then we need to stop left and right from moving on. So I'll just say if is game end, if it's true, then I just return. don't need to do anything. Same thing, I'll just copy this and paste it in this other side and save. So if we go back, okay, move quickly. Yes. So now it has ended. I can't move left or right. Yeah. So yeah, that's fantastic. Whenever there is a car crash in the game, there is an explosion. So it's time for us to, simulate this explosion. And to do that, we're just going to create a function. Yeah, we're going to create a function. And yeah, wow, it's getting long. And this function is just going to be simulate explosion. You could just end that game like how we did, but I feel like people want to see an explosion. So now, this took me, a while, and I was like, you know what? At first I wanted to skip it, and I was just like, I have to do this. So now we're here. So all boxes. So document dot query selector all dot single dash box. Now we want to clear everything on this screen. So everything on the screen would mean not everything. We just want to remove the enemy vehicle we hit and our own vehicle off the screen. So okay, so here we're going to say enemy because we're going to be passing the enemy we hit, and then we're just going to say enemy.forEach, then position, and we're just going to say board position equal to an empty string, and then all boxes dot not dot, that's all boxes position dot class list dot remove, you guessed right, field. So I want to do the same thing, but this time instead of enemy it will just be vehicle. Okay, so let's see how that is so far. So I'm going to copy this, and this has to be where should we put this? Yeah, okay, yes, we'll just put it here after the explosion. So after the explosion, what we want to do is we'll just put the enemy vehicle, then J. Yeah, so let's see what happens. We save, we go back to the screen, and let's see what happens when there is, so see, now everything is gone from the screen. Now it's time for us to make the explosion. So the explosion is we're just painting the screen. We're painting certain boxes. Yeah, so I'm just going to this is how I thought about it. There is an outward explosion and an inward, so it goes out in. Yeah, so I'm just going to, so this is just going to take, it's just going to be arrays that have numbers, because the enemy vehicles and the vehicle were just numbers, so same thing would apply for the explosion. Okay, I hope I didn't lose you there. Okay, so so I'm just going to bring in the the two variables that would do that. So this is box explode, depending on the grid width where we hit whatnot. This is the inner explosion too. So yeah, and we are now going to get the max position of the vehicle, because what we want is wherever position the vehicle is where we want the explosion to be. Yeah, I mean, it wouldn't just explode anywhere. So we're going to say const max position is equal to math dot max, then the vehicle, and then we'll say let explosion length. So the explosion length is, it will determine how many times the explosion will take place on screen. This just gives it the length. Okay, equal to 0. Now we're going to loop through the what's it called? We're going to loop through the box explode, right? Because I mean, that's going to help us to determine where we are going to explode. Yeah, something like that. Now we could either use a for loop or we could use a for each. So let's try out a for each. So that's going to be box explode the for each. So I'm just going to say index, and then I'm going to say all boxes. Then we're going to say the max position minus let's just then put item and change this to what is a position minus position dot class list dot add field. So I want us to see what happens. We'll look at the screen again, look at the browser again. So back. So you can see this is the outer explosion. This is the outer explosion taking place. Yeah. Okay. So now we need the explosion to flash out, in, out, in. Of course, it's starting with out. That's the reason why we did this. So we want it to go out, in, out, in, out, in. So how we're going to do it is that if this explosion dot length is an even number, then we will do the out. Then yeah, we'll do in. If it is an even number, we'll do in. If it's an odd number, we do out. So yeah, like that. Okay, so I hope you get it. So we're going to use like set interval for that. So I'm going to say const explosion clear index is equal to set interval, and then we want this to run every 500 milliseconds. So we're going to say if explosion length modulus 2 is equal to 0, that is if it's an even number, then we'll first clean whatever was, clean the previous explosion. That's what we need to do. Remember, this time we want the inner to show. So what we'll have to do, I'll just copy this, and then that is there. Okay. So I'll just copy this, then here instead of add it will be remove. Okay. I just realized we don't need this index. Okay, and now we want the inner explosion to take place. So instead of, we'll just copy this and paste, and this time it will be inner explosion. Sorry. And then it will be dot add. So that's inner explosion. Else we want the opposite. So we want to first clear the inner explosion. So just say clear outer explosion. Inner, bring in inner explosion. So clear inner explosion. So to clear inner, we're just doing this, paste, and then we will just remove, and then we're just doing this. Okay, so what we want to now do is we want to stop it after some time. It will be good. Okay, let's just see how it will look like. Okay, so out in. Why isn't it? Oh, okay, I know what's taking place, what's happening. So out in, so we are not chained, of course. We haven't updated the explosion length, so nothing is happening. My bad. So if we do, let's just do explosion dot length, let's do plus plus, let's see how it works. Then go back again. Okay, out in, out in, out in, out. It's going to go on forever, and that's not what we want. We want it to stop after a while. So we say if explosion length is greater than 6, then we'll just clear interval, and the interval we want to clear is explosion clear index. So it's just going to run, let's say 6 times. So out in, out in, out in, out in, out. Yay! So that is how we have done our explosion. Yippee! So it's time to have scores on the screen. Yay! So we're going to go back to our HTML, our index.html. So above this, we are just going to say h3 and let's say score. Okay, I think we should do it like this. We're going to have a span. Span. And this span will have an ID, and that's going to be score display. I will start with 0. Yeah. So now we'll go to our me.js at the top. we'll just say let. Okay, so let's first bring in that HTML elements. We'll say score display is equal to document dot get elements by ID. What did we give it? Score display. Let's copy that. Yeah, then we'll put a variable here. Let's see. Let's score equal to 0. So down. Let me see you move, baby. So function increase score. Did I spell that correctly? Yeah. So we're going to just say score is equal to score plus 50. And then we'll say score display dot text content is equal to score. Now, where do we call this function? We'd call this function whenever a vehicle passes, whenever an enemy's vehicle. Why did I call it enemy vehicle? Now it looks like I'm making a mistake. So whenever an enemy vehicle reaches the end, so I think that's check for end. I think it's called check for end. Where is that function? Check for end. Yeah. So that's where we are going to put this. And let's see if that works. Okay. 50, fantastic. Yay. Oh shit. Thank God I moved in time. Yay, bash. Yep. So now we have been able to add this core functionality. We are pretty much done with the idea of this game. We are pretty much done with everything. That's the main idea, that is cars coming down, dodging cars crashing, an explosion. We have scores, but I feel like there are some things we could tweak a bit to just improve it. First of all, I don't want us to use set interval. I want us to use request animation frame. If you don't know anything about request animation frame, I have a video that I have a tutorial that I did on this. I will put this in the description and the card should pop up right now. And I've also used it in a previous tutorial, which is when we're building Tetris. So that should also pop up right now, or it should be in the link in the description. And so I want us to use request animation frame because I mean it's for animation. And then I want a situation when we press a particular key, the cars come down faster. So yeah, let's quickly work on that. So back in our code, where should, okay, we'll just put this here. We comment this out, and then we'll say let. Now I'm just going to bring in a couple of variables, and then initial time, this is the first time, and then we use animation ID. Okay, okay, so we're going to create a function. So if you've watched my previous videos, you know what I'm doing here. So it's just basically the same thing, but if you're watching this and you don't have any idea, don't worry, I'll try to explain what's happening. And so I gotta say FPS, and then I'll say frame interval. So okay, so the frame interval is what we want to do is we want to paint our screen per second. So I'm sure you must have heard something frame per second, and 30 frames per second, something frame per second. So that's what we are trying to do here. how frequent do we want our dome to be painted. That's what we're trying to do with this. So that's going to be frame interval is going to be 1000. This 1000 means 1 second or 1 frame, because this is millimeters, so this will translate to 1 frame per second. And then so if this also kind of mimics like animation, so I would advise you check out the videos I recommended. So then date.now, so this is the initial time the first time we painted on the screen. Then we're going to create a new we're just going to say request animation frame. Now we're going to put in a function here. We haven't created the function, but I'm just going to call this game animation. Okay, so if I do this and I say start animation, if I put 2, so this is going to be 1000 divided by 2, so this is going to give us 500 frames per second. Yeah. So let's save and see what happens. And so it looks like it's just stuck. The screen was just painted once, but we don't want it to just be painted once. We want it to continuously paint, just the way set interval was working. To do that, we're just going to create this function that we put here earlier. I'm going to say function say game animation, and then we're going to say there's something I want to show. There's something I want to do first before I show you guys something. .now, and then we say const time elapsed is equal to now minus initial time. So the current time, so this now is the time we are currently on minus the time that was initially painted, right? And then we're going to say if time elapsed is greater than frame interval, that is how often we want to paint the screen, then we'll just update initial time equal to now minus time elapsed modulus frame interval. Okay, then essentially we'll just say draw on board. So essentially all the things we did here, copy and then paste. I scoot this in and then I uncomment it. Right, so it still looks like it's the same thing, like nothing is happening, but now this is where the magic happens. So we want this to keep calling itself so that it will keep painting. We want it to keep calling itself. So to do that, we will just say animation ID. So I want to put this outside. Okay, it's already outside. All right, thank God. Animation ID is equal to request animation frame and then game animation. So this will call this, I want it to keep calling itself. So let's save. Now we go back. Okay, no, I didn't save. So you can see now it's painting on the screen. It's painting. So it works exactly the same way. The only difference now is that even when there is something that bashes, nothing stops. And why is that happening? That's because, well, we need to cancel the, so where is collision? Check for collision. Yes, collision is down. Okay, check for collision. So instead of clear interval, we're just going to say clear, or is it clear? Or what's it called again? I have forgotten. What's it called again? It's not clear. Oh, sorry. It's cancel animation frame. Okay, so we are just going to say the animation ID. Yeah, so now whenever it collides, it should stop. Yeah. So we want to quickly make it fast when we press a particular key. So just a little bit up where we, okay, right here. I know I should put this separately, but honestly, I think for those who are just starting out programming, I don't want to overstimulate people, so that's why I'm just doing it like this. Yeah, I know. For increasing the speed, because for increasing this, what we want is when we press K, that key or PK, we want it to increase. Then when we remove our hand from K, then we want it to stop. So we're just going to create a function. I'm going to say increase speed, say E, and then if E dot key is equal to K, then we'll just say frame interval is equal to 1000 divided by 15. This is just going to make it faster. I mean, because now the frame per second would drastically reduce. And then we're going to say function to normalize speed. So we're going to say if E dot key is equal to K, then we say frame interval is equal to 1000 divided by 2. Now we'll just go where our event, you know what, I'll just put the event listeners. Yeah, event listeners, are they down? Okay, I think they're up. I'm just going to put the event listeners for this one here. So I'm just going to say window.add event listener. I'll just say key down. Then I'll say increase speed. And then I would say window.add event listener, then key up. Then I'll just say normalize speed. Let's see how that works. Oops. Okay, you can see it increases the speed. Oops. Shit. Yay. Love it, love it, love it, love it. So you guys, you can decide to expand your grid, although I wouldn't advise you do that, to be sincere. I think you should just maintain this. You could increase the height, obviously, but I think we've been able to achieve something good today. I hope you were able to learn one or two things today, and yay. If you've gotten to the end, thank you so much. Thank you. Yay. You're the best Charles Angel. Okay, and if you've learned something, please give me a like. If you've not subscribed, please subscribe. I'm trying my best to put in more videos, so that if you're just coming on board your programming journey, you'll be able to come up to speed with it. And yeah, until the next time, toodaloo, bye.